So hi, I'm John Goodall, Principal Cloud Engineer at Logicata, and this is Keeping On-Call Human. Before I get going, I just want to say, I appear to have specialised in conference danger slots, because I had the fortunate experience of being able to do this last year, and I was fighting for everyone's attention with the beer trolley. Now I'm in the way of lunch, so thank you for holding your hunger for about the next 25 minutes, and I promise to keep this as brief as possible. So what I want to talk to you about today is a very specific problem. How do you stay responsive to customers out of hours without turning your engineers into people who are on edge all night? Because that's the trap. A lot of teams miss things they care about or overcompensate and create a support model, quietly burns people out and becomes completely unsustainable. It's 4 AM. Your phone is screaming. You come online, assuming something's broken, and it's a scheduled deployment. I think most people who have worked on call, and I can see a few people in the audience I know are SREs, have seen this before. They've had this sort of moment. It's not that the message was irrelevant, it did matter. It just didn't matter enough to wake someone up. And that's the awkward category that this talk is about. Not a SEV1, not a P1, but not something you could ignore. Important enough that missing it has a cost, but noisy enough that alerting on it every time becomes a painful problem. The other side is missing it is worse. A customer asks for help, but they don't use the formal escalation path. They don't ring the alarm bell. They drop a polite message into Slack. And from their perspective, that's fine, that's perfectly reasonable. Slack feels immediate because we're trained to think it is. It feels conversational because in the day it is. It feels like they're asking for help because they did. From their perspective, that's exactly what they did. But from the engineer side, from the SRE side, if it lands out of hours, it'll disappear into the background noise, unless it's something that you've designed for. Slack doesn't stop at 5:30. And I apologise for using the American style 5:30 here, but I did. Outside of that time, out of hours, the usual choices are pretty bad. You could ignore it, but then you will miss something. It's not you won't, it's not that you might, you will miss something meaningful. And if you do that enough, you'll lose customers. Clicker didn't work. You could wake someone up every single time it happens. But then you train people not to trust the alerts. And again, the SREs in the room will know what this is. This is alert fatigue, and it is absolutely deadly to an on-call function. Or you make someone watch Slack all night. And what you're doing there is completely counterproductive. You're replacing automation with a human, with toil, and you're burning them out just in a different way. This is the real problem space right here. Not how do we build a bot in Slack, because that's well trodden. How do we create a middle ground between silence and spam? And over the next 20 minutes or so, because I did promise to be rapid, that's what I'm going to talk to you about. But before I do, I should probably tell you who I am. So hi, I'm John, Principal Cloud Engineer at Logicata, an AWS serverless community builder, and that didn't work. And the co-founder of the AWS Brighton user group. And one of my other organisers is in the audience, and the other one, if you want to go and shout at him, is somewhere over there. If you want to connect with me, feel free to scan that now. I'm available later, happy to chat, happy to connect. And I promise there's nothing weird on that, it's just Linktree, it's got the user group and various other bits, there's nothing dodgy, I promise. So what did we need? We needed visibility into customer messages overnight. Fewer pointless wake-ups. And I never promised zero, I did promise to reduce the number. And again, engineering types will know that zero is impossible, driving it as close to zero as possible is a good thing to do. And less chance of missing the message that mattered. Those goals, they sound simple, but they pull against each other hard. The Venn diagram of these, it's a very, very small overlap in how you can achieve that. If you optimize for visibility, You will page people too often, you will burn them out. And if you only optimize for engineering comfort, you miss messages and lose customers. And that's where this is interesting, and that's where the challenge is. It's in the balance. It's trading that off because they're very different. We needed a middle ground. That's what we needed. We couldn't ignore it until morning, and I apparently did ignore my denture glue. We didn't want to wake everyone up for everything. So the goal became reduce the noise without losing visibility. And that's probably the summary of the whole talk. Reduce the noise without losing visibility. So what did we build? A Slack bot. I did promise a Slack bot that watches customer channels and only tells us about things when we're not already looking. That sounds simple, but there's a lot of decisions hidden in that sentence. What counts as a customer message? What counts as out of hours? And what have we already seen? And most importantly, what's worth involving a human? This was the rough idea. And at this point, I wasn't worrying too much about the exact services I was going to use. It wasn't a goal of put some service icons on a diagram to make it look pretty. What I was trying to visualize was the shape of the problem. A message comes in, and we need somewhere for it to land. Somewhere safe, we're not going to lose it, it's not going to fall through the cracks. We need some logic to decide whether it matters, and if we can handle it automatically or not. And then if it does matter, and we can't handle it, we need to put it in front of a human, quickly, easily, and reliably. So the early thinking, as I say, is not what boxes do I want on my diagram, and more, what does it need to do? Because you'll probably hear a lot today about, and you probably heard at the keynote, about how we can ship code much more quickly than we ever used to be able to, but that's only half the point. We need to know what we're doing is the right thing before we start writing anything. And this is where it ended up. And I admit there are now some service icons on here, and I will also admit too, in front of a camera and I don't know, 100 people, I vibe coded the diagram. Because the AWS Diagrams MCP is great, and I really like Kiro for that. So I vibe coded my diagram. Sorry, not sorry. Now, looking at it from there, it looks like probably quite a lot for what sounds like a small problem. But what I'm going to show you over the next half a dozen slides or so is that the complexity is there for a reason. Complexity isn't inherently bad. And what we're doing here is we're building trust, resilience, and separations of concerns. And not just because I like big diagrams. So as I said, the first thing is the customer sends a message, because that's the whole point. We use shared Slack channels to communicate with a lot of our customers at Logicata, because it gives a very low barrier to communication. It's easy, it's quick, it's lightweight, fast, and very natural. Much more natural than forcing things through an email inbox, through a ticket queue. We have those things as well. We wouldn't be a proper MSP if we didn't. And we do ticket the things that come in through Slack, but we don't force the point, not up front. The convenience, though, is exactly why this problem exists. It's a great communications channel, it's great to chat to customers, but it's a terrible thing to expect someone to be glued to all night long. Slack sends the event to API Gateway via a webhook, which is configured in the bot. API Gateway, it's just the door. It's not doing anything tricky, not doing anything complicated, and no heavy lifting. That's intentional. Gives us an entry point that we know where it is, does a bit of rate limiting, but not a lot, and it gives us a clean separation between where messages are coming from and the processing, between Slack and the rest of the system. Could I have done a bit more here? Yeah, probably. I could have done custom auth, I could have done a bit more on the rate limiting side of things, but I didn't want to. I wanted the receiver to own the validation, and I wanted to keep API Gateway simple. That gets passed to a Lambda, and that has a very focused job. It validates the Slack signature, and this is the other part of the security. Because when you send messages through a bot from Slack, it puts a little signature in a header, and we validate that so that we know that it is coming from Slack. It handles the initial Slack handshake, and I'll talk about that more in a little bit. But the short version is, when you register a bot in Slack, the first thing you have to do is give it the endpoint. It tests that and confirms that it's there and it's responding in a particular way. So that Lambda had to handle that as well. It puts messages onto SQS when they're being sent by customers, and it acknowledges that back very quickly. And that last bit matters. I didn't want the webhook endpoint doing a lot of complicated work whilst Slack and the customer was waiting for a response. At the moment, all this is doing is taking the message and feeding it into the system. But the future goal is to be able to respond, threaded messages, tell the customer that we've seen it, tell them that we're dealing with things. To start with, though, I wanted to receive quickly, confirm quickly, and move the logic downstream. And if you're familiar with with event-driven architectures, you'll see that a lot. This pattern shows up a lot. Get the event in, make sure it's safe, and then think about it later and process later. That hands off into SQS. This sits in the middle, and this is a very important part of the architecture. It's a buffer, and it's very easy to think of it as just a buffer, but it is more than that. It's decoupling the receipts from the processing. It gives us built-in retries and error handling with the dead letter queue. It gives us back pressure handling, which again, if you're not familiar, is the idea that the message processor can run at a different pace from the event receiver. So if we get a storm of messages through, we're not going to lose them. They'll sit in the queue until we process them. And it gives us a clean break between ingress and processing. And the observant among you will notice there's two ways of getting messages into the system. There's a polling mechanism, which I'll touch on later as well. And SQS means that the processor only needs one view of the world. It doesn't need to worry about where the messages are coming from. It has one schema it's dealing with, messages look the same, doesn't matter where they've come from. And that gives us a fallback path, which is incredibly important for this design. Now we decide if it needs a human. This is the bit where the system earns its keep. And I say earns its keep, but its keep isn't expensive because this is event-driven, serverless, scales to 0, so its keep is a few pence per run, but this is the bit where the system earns its keep. Because up until this point, we've been moving messages around. We've taken them in, we've put them in a queue, we've validated that we know where they've come from. Okay. The processor is doing a few checks. The first, is this one of our own people? Because we can't be alerting on chatter from internal staff or from staff already helping customers. And this was a bit of a gotcha, because on the version 1 of this, I'd forgotten to account for that. So what would invariably happen when I wasn't on call, because I do have to do this as well, was someone would ask for help, someone would get the page, pick it up, and then start chatting. And then you just get this constant storm of, you've sent your own message to yourself, and that's just not helpful. The second thing we do, and this was in V1, was we check if we're in or outside of the configured working hours window. Because the bot's there, 24/7, it's always on, it's always monitoring. You can't tell it not to do that. So we have to put that logic somewhere else, and that's in the processor. But inside working hours, I didn't want to be sending these messages to people because they're going to read them anyway. That's what Slack's for. So we didn't want to be sending them in working hours. And third, have we already seen this message? And that's incredibly important, because retries are fine. Retries are good, we like them. Sending the same message twice doesn't solve our problem, it makes it worse. And only if we pass all 3 of those checks do we actually then fall out to a human. I like this. This is probably my favorite part, because this is the part where it starts making a decision. It's not just moving data around, we're deciding things. We've codified policy. And we also fail fast. So if any of those checks have a don't send response, we stop. And again, I whinge about cost because I'm cheap, but what that means is the Lambda costs are as low as they can possibly be, because we're finishing as quickly as possible. And it's in this point as well, once we've passed all of those checks and we've sent it to a human, we then write it out to DynamoDB in the deduplication table. This is writing with a time to live, with a TTL of about a day. And what that means is they're cleaning up after themselves, the table keeps itself pruned, and I'm not having to manage an ever-growing table. I didn't want to trade one problem for another, and that's what the TTL helps us with there. Once we have eventually decided it needs a human, and I say eventually, all of these things happen in under a second, they're all incredibly quick checks. But once we've passed through that, we pass it to SNS. This part is deliberately simple, okay? It's intentional. Once the message has made it this far, what I needed was a reliable handoff into, in this case, PagerDuty. And SNS was the easiest way of doing that. And again, I admit, it's an email integration. It's not pretty. I'm not using the API. I'm not sending JSON blobs and structures in the way that you'd expect them to be. It's just using emails. For the MVP, that was great because it works reliably. I didn't have to write it, build it, configure it. I just popped it in, send it to PagerDuty. And that works really well. From there, because we use PagerDuty, and again, SREs in the room will fear that logo, I think, PagerDuty sends a low priority notification to the on-call engineer. That's important. The low priority part matters. Because the goal wasn't turn Slack into the pager. The goal was a soft escalation path, the things that mattered, but that weren't emergencies. That's the reason the system's useful. And because again, we're using PagerDuty anyway, we could use our existing on-call escalation schedules, and this was things that I didn't have to build, because I'd already built it. And we do have a fallback path. So once an hour, we run a polling Lambda that grabs the last hour of messages and feeds them into SQS. That's another reason that the queue is useful, because we have two entrances. Now this started for a pragmatic and, I'll admit, slightly embarrassing reason. I was struggling with the permissions to get Slack to work real time. It just wasn't behaving itself because there was another one and then another one and then another one. And I was sort of struggling with it. But the permission to read messages from Slack on a schedule, that's really easy. So I built this as a, I don't know, a bit of a strop, I think, just to kind of make me feel better about being a real developer occasionally. But it's turned to be a really valuable part of the design because now it doesn't depend entirely on the real-time ingestion path. And I know API Gateway is pretty reliable, it's fairly robust, managed service, and we don't have to worry about it going down, but we can tolerate that now. We can also tolerate weird interruptions in the system where things, we're not going to lose messages because we've designed for that, but this weird middle path between the bot maybe not sending things to API Gateway, or as I say, API Gateway having an issue. We're now tolerant to that. Because both routes end up in the queue, this processor processes them exactly the same, and the deduplication method becomes incredibly important. Because this was the point I was talking about earlier, we do not want to be sending the same message more than once, and 99% of the time, and like all good stats, that's made up on the spot. The messages that are coming in from the fallback, we've already seen them, and that's intentional. We don't want to be reprocessing them. So we check them, yes, we've seen them all, and we move on. This is one of the more production-grade parts of the design, though. What it's done is it's turned a neat demo or a dev spike or an MVP into something that we can actually trust, because we know it's double-checking itself. Now, this is a bit of a dirty word for me. Why not a Lambda lith? Well, I have some pretty strong opinions on them, and they're largely not good ones. But mostly, there's a few actual reasons. Receiving and processing are different jobs. I've spoken about retries and dupes a lot already. One's necessary, the other isn't. And deciding to talk to a human absolutely had to be observable. We couldn't have it sitting in a black box of code somewhere, which again, a lot of this has been Kiro vibe coded because I'm a cloud engineer, not a software developer, and there is a distinction there. And an event-driven architecture gives us a slightly better path to observability, at least for what I'm used to dealing with. Would this have looked simple on a diagram? Yeah. Could I have put it all in one Lambda? Probably two with the fallback path, sure. But the moment something goes wrong, I want to know where. Did I fail to receive, process, notify? Did I send a duplicate? Did I fail to wake the person up? All of these things are very different. They're supporting the same workload, but they are different work. And I get quite, fundamental about that. Function as a service, the function does a job, not several. Receiving and processing are different jobs. The receiver is lightweight and transactional. It validates the URL, like I said earlier, queues it, and acknowledges. That's all it's doing. And okay, that's 2.5 jobs, but it's validating, queuing, and acknowledging. Done. The processor is where all the clever bits live. It's where the business logic lives, and I hate that term because I'm not a business analyst, I'm an engineer. but it's where we decide whether a message becomes an interruption. And the fallback purpose has an entirely different purpose. The fallback path is a different thing, okay? We're grabbing the messages and we're proceeding. That's there for reliability. It's not there for critical path work. It's the idea is that it's a backup plan. And splitting them into their own lines keeps each component easier to own and maintain in the future. Because this isn't something that we've done just for a demo or to get me on stage, but it does have that effect. This is something that we actively use every day to support our workloads, keep our engineers happier, and it's something that we're actively building on. Retries are necessary and duplicates aren't. So Lambda and SQS, they retry by design. It's intentional. And it's great, we like that, because again, I've not had to build that. Lambda is using long polling, it's passing out to the DLQ, that's just baked in. I just tell it about these things and it handles it. But that should never, ever turn into a duplicate if we can help it. If we've seen the message, don't send it. Because what you absolutely don't want is an infrastructure blip or a retry to become a duplicate pager for a human. So the system has to tolerate them. And deciding to talk to someone must be observable. Now this is really the heart of any production system, and I'm seeing some glazed over eyes, so I'm going to probably have to speak a bit faster. But this is the heart of any production infrastructure, okay? If you need to talk to someone, you have to be able to observe it. Because once you put automation between your customers and your engineering team that help them, you have to be able to answer some uncomfortable questions. And I've said this already, but did I see the message? Did I suppress it? Did we break? Did we notify? Have we done that too often? Because if you can't answer those, people won't trust it. And if they don't trust it, they won't use it, they'll route around it. And this is the bane of shadow IT, and I must admit I've done this before as well. So the monitoring is baked in. We've got CloudWatch logs, alarms, metrics, all the usuals in all the usual places. Because if we can't see the failures, we can't trust it. And if we can't trust it, what was the point? It may as well not exist. So I want to take you back to that little 4 AM moment. Your phone is screaming. But this time it's actually a problem. That was the goal here. Not no alerts, because we run a 24/7 function and things will break. Not perfect automation, though we're pushing to put more in here, so we're not just saying, is it staff or not? We're trying to filter things out so that the system can work out, this is a deployment, we've seen this, handle it. But that's the goal. Better alerts. Alerts that preserve visibility for customers and sanity for engineers. And if there's one thing I'd like to leave you with, the success condition for your on-call system isn't technical correctness, or isn't just. It's whether the humans can trust them and live with them. Thank you.